Okay, we want to look at a double integral in dy dx, with the integrand being something that you can integrate with respect to y first. And so you must switch the order of integration. So first recognize the order that it's in, dy dx, and that means that y is first. So y goes between x squared and 4, and x goes between 0 and 2. From this you have to get a good drawing of what the region is. Now dy dx is done with a vertical rectangle that is moved horizontally. So what that means to us is that the x squared is the lower bound and the 4 is the upper bound. And then it gets moved from x equals 0 to x equals 2. And so y equals x squared is your parabola. Y equals 4 is a horizontal line. And we want the lower bound to be the x squared and the upper bound to be the 4. And we only want x's from 0 to 2. So with all that said, our region should look like this, where we have upper bound 4, lower bound x squared, and this moves from x equals 0 to x equals 2. Now that we have the region drawn correctly, we should draw another region, and then do it as dxdy. In dxdy, we have a horizontal rectangle that gets moved vertically. And so the low bound will be the y-axis and the upper bound will be the parabola. But we need this in terms of x equals. The y-axis is called x equals 0. This parabola originally was called y equals x squared, but the x equals version of that, we take the square root. This is the positive x, and so we go x equals the square root of y. And these are our bounds on the inside. Now, when it comes to the outside, we have to visualize this thing moving from a low value of y to a high value of y. The highest value of y is 4. And so that's going to be the upper bound outside. And so we have the bounds now, and it's our job to set up the double integral. So we have the integral on the outside from 0 to 4. The integral on the inside from 0 to the square root of y. It is now a dxdy integral, and let's take a close look at the integrand. Switching it is beneficial to us because this function is constant in x, okay, with respect to x. It's like integrating a constant. The integration of e to the root y over y with respect to x is just e to the root y over y times x. And then that x gets evaluated from 0 to root y. And then we have this outside integral of 0 and 4. So we put the root y in, and we put the 0 in, and we subtract, and so what we end up with is the e to the root y over y, basically times a root y, officially minus 0. And so that outside integral, let me erase the minus 0 part. That outside integral goes from 0 to 4. It's a y integral, and we can simplify rad y over y simplifies to be a rad y on the bottom. Now, why is that beneficial to you? Why is that a good thing? why can't we now do this integration? We have to get ready for u substitution. If we let u equal the square root of y, its derivative is 1 over 2 square roots of y. You have 1 over the square root of y times everything by 2, and you can figure out how to sub for that. When you put in twice du, you'll be subbing for 1 over rad y dy. And so, we'd have an e to the u, and then we have a twice du as our integral. It's up to you what you want to do with the bounds. It seems like a nice easy switch, so let's go ahead and execute the switch. When x is 0, the square root, when y is 0, the square root of y, that's what u is, the square root of y is 0. When y is 4, the square root of y is 2. So you can use these u bounds, go from 0 to 2. And we're done. We have 2e to the u, and we'll put in a 0 and a 2, and we will get the answer of e squared minus 1. You know, e to the 0 is a 1, and then that thing gets doubled. If you want to distribute and match it to one of these answers, you're going to get 2e squared minus 2. Okay, so I've provided you the structure on how to do these problems. Take the bounds, write the inequalities, and focus on the function part, and make sure you know what the format of what you're using is. dy dx is vertical moved horizontally, and the low bound and the high bound, the upper bound, need to be identified so you can correctly get the region and therefore correctly switch the region and get the new bounds. Keep the region but switch the order of integration and find out what the new bounds are. It's not a simple thing of just quickly just switching them up or interchanging them. You have to actually go through the drawing. If you do this without a drawing, your chances are you're going to probably make a mistake. Okay, so that's that question. Let me know if you have any questions in the comments.